I'll try my best.
You try your best.
Mm.
Go to your dashboard, you will see previous recording of the classes we had. So you can do what to check it and consume them. So if there's anything you need as a question, you can do what to ask for clarification. Is that okay?
Okay. Thank you.
You're welcome. So like I said, today we are moving to the sixth chapter in your JAM syllabus. So you're expected to understand atomic structure and chemical bonding. So it's a very important topic in your JAM syllabus that they want you to know because they'll be testing you on this topic. So the first thing we need to check is what is an atom? Nobody will ask you what is an atom, but I believe you all know what an atom is. An atom is the smallest particle of an element, right? That take place in a reaction or that can retain its chemical properties. So you can write down the definition of an atom. So I believe you should understand what definition is. Uh, Write it down here. Next. The next thing you need to consider is what is the structure of an atom. Like I said atom is the smallest particle of an element. In case you don't get me, as the smallest particle of element. They won't ask you for the definition. Not at all. So let's quickly check the structure of an atom. Atom contains of three things. Just remember your proton, your neutron, and the electron, right? Let me check the number of students on the call. Adeni, Joseph. Okay. Becky, I just joined the class. Joseph, same to you. I just joined the class. Becky, I can't hear you.
I said yes. Good afternoon.
Uh, are you very good in chemistry before?
Not really.
Not actually, what is it?
I said not really.
Not really. Can you access your dashboard?
Hmm?
Like, can you access your dashboard, your class dashboard,
My
your personal dashboard? Have you been registered?
mm,
So go to your dashboard, check recordings, video recordings, so that you can make use of the videos in the previous classes. Is that taken?
okay, I've done that before.
You've done that before. Okay. Okay. And also, Stephanie, my girl, Alpha, hey, Ugo, all of you. Stephanie, you didn't come for the last class. What happened? Ninky Gold, you too. As well. So let's continue. So today we are taking atomic structure and chemical bonding. I believe you understand what an atom is, and we want to check the structure of the atom, but then you have to understand that atom consists of three particles: the proton, the neutron, and the electron. Let me just give you a table. The particle, the charges they have, the mass and the location. These are not jam questions, no, but there's things you need to know as we move forward. Once we get to jam question, I will tell you. So let's start with photon. Photon is a positive charge, right? Isn't it? Neutron. From the word neutron, it has the word neutral. So it has a neutral charge, which is 0. They get that. And if you look at photon, it was P that started photon, and P start positive. So in case you want to forget, so P for positive, P for photon. So that's P. They get it. Neutron takes the verb neutral. So anytime you hear neutron, it was from neutral. Neutral simply means no charge. So it has 0 charge. So since we have positive and neutral charge, that means the last one will be negative charge, right? So I'm teaching you this in case you are confused in your exam. So electron has a negative charge. So the mass of proton and neutrons are the same thing. They are 1, 1. Why the mass of electron, when it was made, is not up to 1. It is 1 of 1,836. So the location, both the proton and the neutron, they are located in the nucleus. They are inside the orbit, the shell. Both the proton and the neutron, they are located in the nucleus. But the electrons, they revolve around the orbit, around the shell, right? So they are located around the shells. So that's the charge mass location of the three particles, the proton, the neutron, and the electron. So there are some key points that I want you to understand under this before we proceed. Number one, anytime you hear the word atomic number is equivalent to the number of protons. We'll be working on these things later on. So when you hear the word atomic number, is equal to the number of protons. Isn't it? And mass number is equivalent to the number of proton, the addition of number of proton and neutron. When you add your proton and your neutron together. So from here, we can easily calculate the number of proton by making a distribution of the formula. Isn't it? In case I have to calculate the number of proton or of neutron. So that would be N equals mass minus proton, sorry. Or since number of proton is equal to number of atomic number, we can say neutron is equal to mass minus atomic number. Is that okay? Are we together? Okay, good. Thank you. So another thing they always ask is when they ask for the nucleons. In case you see question, if they are not asking based on mass number of neutron. If you see nucleus, NuC, LeONS, nucleus is equal to the photons plus neutrons. In case you see question on that. Yeah. So that's all about that. All these things they may not ask actually. If they ask you, what is the number of protons in sodium? Since the atomic number of sodium is 11, what will be the number of protons? Anybody? Anybody there?
Sorry, so what's the atomic number?
Atomic number of sodium. I don't know. Sodium is number what in the periodic table? I forgot in gifts.
Sodium. 11.
11.
Okay, so then the number of protons will be 11.
22.
Yeah?
Hmm?
The number of protons will be what?
23.
Number of proton will be 11 also now. I said atomic number is equal to
Shocked me.
number of proton.
She has answered it. I'm talking about mass number.
Mass number is proton plus neutron.
Yes. Mhm.
Is that okay?
Yes.
And even for your atomic number also can be equal to your, that is if it's a neutral atom. Your atomic number can also be equal to your electrons. But it must be a neutral atom. Neutral atom simply means there's no charge. These are we together? So they can ask you that when is your proton equals to your electron. So the only time your proton and your electron can be the same thing is when the atom has a neutral charge. Or they can ask you that there's an element that has atomic number 11, proton number 11, electron number 11. State the reason. It simply means the atom has a neutral charge. This is that taken. But anytime you see Na plus has a type of proton, it has a type of electron, it has a type of atomic number. They are not the same. Is that taken? Because it has a positive charge already. So the electron number would have actually reduced. Since it is positive, it has lost one electron. Instead of 11, it will be 10, like that. Is that taken? But the atomic number still remain 11. Hope that is taken. I believe we should be used to this already. So let's move to one of the important questions that JAMB will ask you. It is development of atomic theory. They like this question. They'll be asking you some theories. They ask you about theories. They ask you about limitation. So I will just give you the, sorry, give me 1 minute. Let me start the phone. Hello. Sorry, I thought I have muted my mic. So we want to move to the second part, which is development of atomic theory. And this is JAMB favorite. Do you all understand this first part before we move to the second part? Hope everybody understand. If you understand, can I see your thumb up? Okay, Paul. All right, let's move to the development of atomic theory. So this one they may ask you please atomic theory. That's what I short to AT. Is that okay? They can ask you the atomic theory. They can ask you the limitation. So this place you have to read it and understand. It is very, very important. Either they ask you that's on atomic theory or probably this guy Thompson, DJ Thompson, can ask you anyone, and they can ask you the limitation, maybe Rutherford or Boyce model or anyone. We have many of them, but they always ask Paul, Pauls, Rutherford, Thompson, and that's on atomic theory. So what does that term say? Let's start with the first part. The Dalton's atomic theory. So that some say matter is made up of indivisible atoms. Can I write it down? Matter is made up. Do you want me to write? Matter is made of indivisible atoms. The second thing is stated is that atoms of the same element are identical. Atoms of the same element are identical. Those are the two things, the summary of Dalton's atomic theory. And what do we mean when we say matter is made up of indivisible atoms? What does it mean? If you look at the space you occupy, I mean around you, you understand that there are some things around us are made up of. For example, everything around us, like air, like water, like the things you can touch, you can feel, like your phone, like wood. All of these things, they are made up of tiny particles that we call atoms. So they believe that there's nothing that ever existed that is not made up of atoms. So that's why they said matter is made up of indivisible atoms. And at that time, the word indivisible simply means they did not believe that atom can be broken to smaller parts. So that is the last part. That the last thing you can break. For example, maybe you're trying to break food into pieces. Maybe you want to cut one grain of rice, you want to cut it into pieces. Someone can cut it to 10, another man can cut it to 4. But it will get to a point that you know that I can't cut it again. I don't know if you get my point. So they said that atoms are made up of indivisible atoms. So that is what they mean. So some people will say, which is the modern correction? They said, we said atom contain 3 particles: photons, neutron, and electron, isn't it? Now, if we say atom is the smallest particle and they are indivisible, how come do they contain photon, neutron, and electron? Is that taken? So this is one of the limitations of atom atomic theory. Though he said matter is made up of indivisible atoms, but then modern theory made us to understand that atoms can be divided into 3 particles: into proton, into neutron, and into electron. Is that taken? So what makes atom atomic theory to be correct is that though matter is made up of atoms, but atoms are not truly indivisible. They can be divided. Please, do we all get that concept? Am I making sense, please? All right, very good. So let's quickly move to the second one. I said, what's the second point that I gave to you, sir? I said atoms of the same element are identical. Can somebody explain that concept? Anybody? Mickey Good, do you understand that? When we say atoms of the same element are identical,
No,
what do you say?
I don't mind.
Are you talking?
Yes, are you not hearing me?
I can hear you now. What do you say? When we say atoms of the same element are identical,
I don't know.
I don't know, Abi. Do you have anybody that can? I want you to understand the law, the theory, so that when you are reading, it will be easy for you to. Anybody? Do you have anybody that I want to help? Can you unmute your mic and talk?
Okay, atoms of the same element are identical in the sense that they have the same chemical, physical properties, melting and boiling points.
Very good. They behave the same way. So when we say atoms of the same element are identical, they have the same behavior. We can say that children in the same family, they have similar traits. Is that taken? Probably, yeah, you look like your mom, you look like your dad. You talk like your mom, you talk like your dad. So that's just it. So they have the same or similar properties. Is that taken? So let's move uh, to the next thing. The limitations is that atoms are divisible. If they ask what is the limitation of the atom atomic theory, hope you know it now, and hope you know how that is a limitation. Everybody, are you guys sleeping? The limitation of the atom atomic theory is that, you know, he said that matter is made up of indivisible atoms. Yeah, do you still remember? And I was explaining to you that modern theory made us to understand that atoms can be divided into three particles, into proton, neutron, and electron. Now, you still remember? So that means his theory is not well full, like it's not complete, because atoms are divisible. They have subatomic particles. Is that it? In case they ask you that which theory has the limitation of indivisible atoms, so you should know that that is the atom atomic theory. Are we clear with atom atomic theory? So let's move to the second part. I think it's only Gift and Paul that is in the class. JJ Thompson, Titi, well done. If I catch you, enter my DM today. Oh. I have a gift for you. Don't enter my gift. Oh. So JJ Thompson. So what is the theory of JJ Thompson? He discovered the electron. Please I want us to finish this chapter today. Oh. So let's be very, very fast. Because we are having your test on Friday. Discover the electron. And he proposed the Plum body model. Assuming you are writing JAMB now, I would have explained how this Plum body model arises. But then JAMB will not be asking you all this question. So just know these two. He discovered the electron and he proposed the Bloom body model. The third one, Rutherford. Rutherford discovered the nucleus. Hope you are writing. We still start question and answer. We should start. Discover the neutron. What else I did there? Okay, it said positive charge are concentrated in the nucleus.
Is it neutron or nucleus? I don't know.
Discover the nucleus. Nucleus, not neutron. Thank you, Jai. Positive charge are concentrated in that same nucleus that he first discovered. The Boy's model. And if they ask you, which scientists prove that atom is mostly an empty space, it is this Rutherford. Can add it as part of the thing. He said atom is mostly empty space. Guess the answer. All together. So the Boy's model, I should be dictating self. I think it's somehow. Electron moved in a fixed energy level. That is, they move in a fixed energy level. And he also explains atomic spectrum. Explains atomic spectra. I know you don't get it. It's energy levels. So these are basically the four things that they'll be asking you. But the other scientists that they, if they want to ask you, you can go and check your passport. They can ask you who discovered what, who discovered what. They can ask you who discovered the Bloom body model, who discovered the electron. Please go and pay attention to it so that you'll not be missing scientists together. We started with the atomic theory, right? Do you remember what you discovered? Please read it after the class. We also have a scientist called Millikan. He was the one that determined the charge of an electron. In case the one asks. But this one is just like maybe once in 5 years. But nobody can tell. Millikan. So it determined the charge of an electron. Yes, they always ask, but it's just once in a while. So it's possible you've seen it before. So have you written Millikan? Determine the charge of an electron. Please, are we all together? And mostly too. So it was one that he contributed to the periodic table. He established that atomic number are basis of periodic table. In case they ask this guy too. Established atomic number. I short atomic number to be AN. Please write it in full. As basis of periodic table. So these are I don't think they can ask for any other sciences apart from this. Determine the charge of an element. So everybody, check these 6 scientists, and quickly count their theory. Matter is made up of indivisible atoms. The atom atomic theory. So anything, the first two things you need to know when you hear the word atom atomic theory, he said matter is made up of what? Indivisible atoms. So the theory was right, but it was not totally correct because every matter is made up of atoms altogether. But atoms itself, they are divisible. Every matter is made up of atom, but atom is divisible, and that is his own limitation. And the other thing he said is that, another thing he said is that atoms of the same elements are identical. Yeah, atoms of the same element are identical, and thank God we've been able to explain the two concepts. Please calm it. Yeah, calm it now within 30 seconds. Matter is made up of indivisible atoms. Matters are made up of indivisible atoms. Matters are made up of indivisible atoms. Matters are made up of indivisible atoms. Atoms of the same element are identical. They're identical. They're like family. They're identical. Are you done with that? The limitation is that atoms are divisible. You know, we said atoms are stable particles, proton, neutron, and electron, right? So that means they are divisible. Let's move to J.J. Thomson very fast. We are reading, J.J. Thomson said he discovered the electron and he proposed the Bloom-Pondy model. So he discovered the electron and he proposed the Bloom-Pondy model. Datum, what does datum discover? Anybody? Datum atomic theory. Gifty, Paul, Adeniyi, Joseph, Titilola.
I think he discovered I don't know, but I think he discovered indivisible atoms.
Indivisible. He said matters are made up of indivisible atoms.
Yes.
That was what we just read. That I'm reciting it since morning. Hey, wait. Okay. J.J. Thomson discovered electron, proposed the Bloom-Pondy model. Anytime you hear the word Bloom-Pondy model, J.J. Thomson, J.J. Thomson, J.J. Thomson discovered the electron, proposed the Bloom-Pondy model. Who that for? Please quickly read these 4 things. I want us to proceed now. So should we move on? Okay. I believe everybody knows Bohr model. It explains atomic spectra. How electrons move in fixed energy levels. Millikan determine the charge of an electron. Mostly establish atomic numbers as basis of periodic table. Okay. If they ask you the question and you forget it as well. Let me ask this question. An atom has atomic number of 11 and mass number of 23. Who can tell us the electron? Okay, an atom has atomic number of 11, mass number of 23. The atom is a neutral atom. They ask us to find the proton, the electron, and the neutron. Anyone?
Okay, so I think the electron is 11.
Electron is 11. What about the proton?
The proton is 11.
How about the neutron?
The neutron will be 23 minus 11. 12.
Very good. I hope we all understood. Let's move to isotopes. Do we all understood that? Hello. We are doing for those that are just joining for the first time, we do quiz after each class. So be prepared. We do quiz, so and you can't call a friend, you can't do anything. Just nobody will pay you out. You pay yourself out. So let's play with isotopes. What are isotopes? Isotopes are atoms of the same element. Isotopes are atoms of the same element with the same atomic number. Isotopes are atoms of the same element with the same atomic number, but different mass number. Isotopes. Sincerely, I shouldn't be writing for you because it will make us to be slow. Are atoms of the same element with the same atomic number, AN, but this write your atomic number in full, but different Mn mass number. They have different mass number, but they have the same atomic number. So we can have an element, let's say A, we have something like X, we have something like Y, and this same element A has Z here, but still has Y. This one on the top is what we refer to as mass number. Are we together? And this one with downward is what we refer to as atomic number. Please, are we together? Please, are we together? Sorry, I lost my network. So let me recap again. I was telling you that if you look at the top here, you can see the first isotope, the first behavior of this element here, element A. It has X at the upper part and Y at the lower part. Later, it still has Y at the lower part, but the X has changed to Z. So that's what they are referring to as. The one at the top is what we refer to as the mass number. You can see that it's changed from X to Z, right? That is a mass number. The mass number of an element is not the same because isotopes help us understand that atoms can have the same atomic number and different mass numbers. There are some elements that can behave like that, that behaves like that. Look at the atomic number. You can see Y downstairs, Y downstairs. the same atomic number. Let's say, for example, if you remember chlorine has 35CH17. You remember? And it has 37CH17. So you can see that the mass number of chlorine is still consistent. So it is different. Sorry, it's not consistent. This is the mass number. From 35 to 37, it has changed. Look at the atomic number. You can see the atomic number is still the same. If they ask to find the proton here, the proton here is still 17, right? If they ask to find the neutron number here, the neutron number here is 18, right? But the neutron number here is 20. You can see the changes that arise from there. Please, are we together? My people, where are you? Are you sleeping? No time to sleep yet. So I believe in another isotopes. Like hydrogen have 1H1, 2H1, 3H1, and all. Let's move to, I will still give you more, but sharp zipping it little by little. Let's move to another topic, is using relative atomic mass. Please write it in full. Using isotopes. They will have to find relative atomic mass using isotopes. So how do we get that? So the formula is the relative atomic mass, RAM, is equal to the summation of the product of isotopic mass multiplied by percentage abundance. Please, once it's 30 minutes to go, please someone should remind me so that we can start the quiz. Question. Abundance, percentage abundance. Everything divided by 100. Do you understand it? What this simply means, let me explain this formula. It simply means that you will multiply each isotopic mass by its percentage abundance, and you will now add them together. Titi, it means that you will multiply what? Each isotopic mass by its percentage abundance. Then you add it together. Then you divide it by 100. Gifts. It means that you will add each isotopic mass by its percentage abundance, and you add them together. Then you divide it by 100. Joseph, hope it is clear. Hope that is clear. Let's say, for example, they say chlorine has 2 isotopes, right? Someone should do this. Good. Chlorine has 2 isotopes, right? 35Cl17 and 37Cl17. So that is why we have that 5.5 as the molar mass. So if they ask to calculate the relative atomic mass, it's very simple now. So they say we should multiply the isotopic mass by percentage abundance, isn't it? Now, in the question, they will give you the percentage abundance of 35Cl17 is actually 75%. So let me write it very well so that you're not. So we have 35Cl. They will not give you the atomic number. They can just write 35Cl alone. It's still the same thing because they expect you to know the atomic number of chlorine. And they give you this one to be 75% and 37Cl. So this is still an isotope. Please, in case you don't see the atomic number there, don't Okay, and they asked you to find the relative atomic mass of this. You know, the formula said isotopic mass multiplied by the percentage abundance, right? Then we add it together and we divide it by 100, isn't it? So the isotopic mass of the first one here is 35, right? The second one, the isotopic mass is 37, isn't it? The percentage abundance of the first one is 75, and the second one is 25. Are we together, everybody? So if you have to go with the formula, that would be summation of what? That means we are adding the first isotopic mass, that's 35 times the percentage abundance is 75, Abi. Then we had it. What's the second one? 37 times 25 now. Then you close the big bracket. Then you divide it by what? 100 bar. So somebody help us. Anyone with calculator. What is 35 times 75? What is 35 times 75?
2,625.
So 2,625 plus. What is 37 times 25?
925.
925. So everything divided by 100. So add 265 plus 925.
85.5.
2,625 plus 95. What do you
That's
call it?
3,550.
2,550 divided by 100. So that will give us 5.5. Do you see? So that's how we know that the relative atomic mass of chlorine is 35.5. Your periodic table will give you. So in case you don't want to cram, sometimes they can ask you to calculate. They can give you an unknown atom. They can say a atom X has a relative atomic mass, or let me say it has an isotopic mass. Let me use that one of 23, and it also has another atomic mass of 20, maybe 23.8, or 24. They can ask you to find the relative atomic mass, considering the percentage abundance of that element to be this and this. So they expect you to find the relative atomic mass by using this formula. It's very simple. Just multiply your isotopic mass by your percentage abundance, and you add it together. In case you have something like hydrogen, hydrogen has like 3 isotopes: 1H1, 2H1, 3H1. So that means you're adding 3 things together, right? So please, the summation depends on that the element contains. Is that taken? So let's proceed to. Do anybody want to talk? I can hear your sound now. Please talk if you want to talk. I can't see if you are raising your hand.
Okay, it is me. I wanted to ask because you said hydrogen has 3 types of isotopes. What if in the question they give you only 2?
They gave you only 2.
Yes.
So you will not change the question for them. Gifts. You do what they ask you to do now.
Okay, you said we just those 2.
You just use 2. What if they give you 2? Use 2. But if they not give you 2, they ask you to calculate the relative atomic mass of hydrogen. That one you should know that one offhand. But if you don't know, you have to find it yourself. You should know the relative atomic mass of every element. Especially in first 20 elements in the periodic table. Know their relative atomic mass. There's a cheat behind it. All the atomic mass, all the elements with that they are even, just multiply it, the atomic number by 2. But don't let me give you that with 2. You have to pay. You know, magnesium should be 24. Carbon, what do you remember carbon? The only atomic of carbon is what? Sodium is 23 now. You know, it's even. But that's just calcium is 20 atomic number. So the mass number, the best atomic mass is 40. So they are let's say trick to hold these things. But we cannot be doing that at the moment. You just have to just memorize the formula and you'll be able to do something about it. So let's go to let me check the time. Okay, we still have some time now. It's 1:30. That's good. Let's go to electron configuration. Electron arrangement. It's a very important topic also. Please, I'm just giving you guys one example. Once we start the quiz now, you see other questions from your past questions. Please do well to introduce yourself to, let me use red pen. Electron arrangement. Do you still remember the maximum electron per shell? That is 2n square, right? All of you are forgetting how the rules work. Before we go to electron configuration, the maximum number of electrons per shell should be what? 2n square. It's 2n square. And the shell will fill from the lowest energy to the highest energy. So the filling of shell or orbit starts from the lowest energy level to the higher energy level. Is that taking? Is that taking? All right, so let's check. Sorry, guys, I'm coming. Sorry. Sorry, guys, I had a visitor. All right, so where are we? So do you remember the rules? I said the maximum electron per shell should be what? 2n square. And I said the shell should fill from the lowest energy level to the highest energy level. So let's start with the electric configuration of which element should we start? Let's start from the simplest. So hydrogen. What's the atomic number of hydrogen? That's the first element, right? It's atomic number 1. So the electron arrangement will still be 1. Lithium would be 2. Okay, helium would be 2. Since the atomic number is 2, lithium will be 3. So that would be 2, 1. Or do you want me to be writing it down? Let's move to the higher one. Carbon. Carbon is atomic number 6, right? So since the highest fill for the lower energy level is 2, so therefore for this guy, carbon, that would be 2, 4. Oxygen is 8. That would be 2, 6. So 8 is the highest for the p orbits. Now we have SPDF. Now, if we are talking about sodium, the atomic number of sodium is 11, right? So that would be 2 for the first part, 8 for the second part. So we only have 1 left. And that is why sodium will always lose 1 electron to have Na plus. Which other one can we check? Chlorine is 17, right? So the first is 2, the second is 8. The last one should be 7. So argon will be 288. Since it's element number 18. Calcium is 20, right? That would be 2, 8, that's 2 plus 8 is 10. That would be 8. 8 is the highest. The highest number. 2 plus 8 plus 8, that's 18. So the last one will be 2. So if you rather lose these 2 than to gain 6. So that's why we have calcium to be 2 plus. Is that taken? So let me go deeper. I think you should know that. Let's go to the atomic orbitals. let's start with the s orbital. All these ones, they are very simple. Let's move to atomic orbitals. Oh, my mic has been muted since morning. This is serious. So sorry. So let me recap. Oh my god. So we are moving to atomic orbitals. So we want to check the s orbital and the p orbital for your jam syllabus. That's what they asked you to know. So this is not why. So you guys are safe. So s orbital, we said there are two things they can ask you. They can ask for the shape or the maximum number of electrons each orbital can contain. So the first one I said spherical shape. S as S. S orbital. Spherical start with S. Spherical shape. And it can hold a maximum number of 2 electrons. And P has a dumbbell shape. And it also a maximum of 6 electrons. Is that taken? Do you understand the s orbital and the p orbital now? I believe so. So let's quickly move on. All these things I will ask you a question after the class. So let's quickly move to the 6th topic for today. We are moving very fast today. Periodic table and periodicity. So in periodic table, number one thing the first thing you need to know this. Anybody, do you want to talk? You want to say anything? Okay. The first thing you need to know in the periodic table is that there are some arrangements like a law, like a blocks. We have the groups, we have the periods. So in case they ask you, element that contains same number of valence electron belongs to Is it the vertical or the horizontal? The vertical means the group. Let me just write it down for you. That you not. So we have the groups and the period. The groups, they are the one vertical. Vertical means something like this. Period means something like this. Horizontal. Is that taken? All right. So in the groups, they have the same number of valence electrons. Valence electron simply means the last electron in the outermost electron in the outermost shell. For example, calcium has 2,8,8,2. So the valence electron of calcium is 2 plus, right? Is 2. Potassium is 2,8,8,1. So that means potassium belongs to group 1. Calcium belongs to group 2. So aluminium is element number 13, that's 2,8,3. That means aluminum belongs to what? Group 3. Please, do we get how it's been arranged? Like carbon now. Carbon is atomic number 6. So that it will have 2,4. So that means the last electron here is 4. It belongs to group 4. So just look at the last number in the outermost shell. That would be the group. Let's say, for example, chlorine. Chlorine is element number 17. So that would be 2,8,7. Isn't it? That means chlorine belongs to group 7. These are the halogens family. Chlorine, fluorine, iodine, astatine, all those and which other one, sir? Lithium.
Bromine.
Bromine, sorry. Lithium is group 1, 2,1. So bromine, chlorine, fluorine, all those guys. Sure. So the concept is just that. Let me just write it down for you. How do you recognize groups? The valence electron. So hot groups, they have the same number of valence electron. So when we talk about group 1 elements, it simply means at their last shell, you must see 1. For example, lithium, sodium, potassium, cesium, rubidium. All this one, it doesn't concern you. When you get to your university, they will be teaching you other one. But this first 3 parts, lithium, sodium, potassium. If you look at it, sodium is element number 3, right? That's 2,1. You can see 1. Sodium is element number 11, isn't it? It's 2,8,1. You see? Potassium is element number what? It's not 19. That's 2,8,8. What's the next one? 1. Please, are we all together? Are we all together? Do we all get that? So groups have same number of valence electrons. Another thing you need to take note under that group is that they have similar chemical properties. Similar chemical properties. Similar chemical properties. So I believe you can tell us if they ask you which elements are in the same group. I believe you can say, let's say they write magnesium, they write calcium, they write sodium, they wrote carbon, they wrote sulfur, they wrote potassium, and they ask you to, maybe they say A, maybe they label this one Oma figure 1, Oma figure 2, Oma figure 3, Oma figure 4, Oma figure 5, Oma figure 6. Now say A 1 and 2 and 6 are correct. Do you know all those jam questions? You can say 2 and 3 is correct. They can tell you. So you should know that magnesium, calcium, they belong to the same group now. It belongs to group 2 because magnesium is 12. That's 2,8,2, right? Calcium is 20. That's 2,8,8,8, 2,8,8,2. That's 20. Sodium is 1, group 1, 2,8,1 because that's atomic number of 11. Potassium is also 11. Group 1, sorry. Atomic number 19. That's 2,8,8,1. Sulfur. I think sulfur is 16, Abby. That's 2,8,6. Isn't it? All these things, it has been a long while. Carbon is not what's the carbon? It's not 6. That's 2,4. So I just wanted to hope you shall understand what I'm trying to say here. That's the most important thing. So let's go to period. Let's go to periods. Periods, in case they ask you, they are horizontal. We call it across the period. Across simply means you are moving from one place probably to the right or to the left. When we say down simply means group. Period simply means across. Is that okay? So in periods, let me erase this so that it will not confuse me. Period always have same number of electron shells. What did I say? They have same number of electron shells. Let's say let me start with period 1. For example, what are the elements in period 1? Is it we have lithium now? Lithium has how many shells? That's 2 shells. Hello, are we there? Period is when we are moving to this place. So what's another period is? So I'm talking about period 2. Sorry, this is not period 1. This means I'm even forgetting it like this. So we have magnesium. Magnesium is in group 2, but it's also in period 2. How many atom shell do you have in magnesium? Wait.
Magnesium is period 3.
Magnesium is period 3. Sorry, I want to remember the elements in period. Okay, we have lithium, we have boron, beryllium. Sorry.
Yes.
So sorry for that. We have carbon. So if you check all these things, let me list them out. I'm sorry, it's been a long time. Lithium, we have beryllium, we have boron. What else? There are so many, carbon, oxygen, nitrogen, and all. So if you look at the number of electrons, number of shell that they will have the same number of shell. For example, lithium has 2. If you check beryllium should be B, not B. Beryllium has atomic number of 4. So that means it should be 2,2. So it will have 2 shells also, right? 2 at the first, 2 at the last. Isn't it? If you check boron is 5. Atomic number 5. It also have 2,3. That's 2,3. So that means 2 in the inner, 3 at the outermost. Carbon is element number 6. So that would be 2,4. Isn't it? 2 in the inner, 4 at the external. Nitrogen is 7. That's 2,5. 2 in the inner, 5 in the external. Oxygen is 8. That's 2,6. 2 in the inner, 6 in the external. Please, do you all understand how periods works? Same number of electron shells. Is that taking place? Please, are we all together? Please, if you know it up to this extent, or let me say, if you don't know it, can you signify? So that we really should. Hope I'm not rushing too much today. Anybody? Confidence. Are you trying to tell us you don't understand it? You understand? Which one? Oh? Which part? Is it from the periodic table? Confidence, talk to me, please. Okay, the periodic table. And it's very simple. You know, it has been a very long time. Hope you understand the hex and the p of beta. So the periodic table, I'm just trying to give you a little introduction. I believe you guys should still remember what periodic table is. It gives this organization of elements. Yes. Even the transition elements, the transition letters, and all these what's it called? High radioactive elements. So the one that they want you to check is actually group 1 to, I mean, the first 20 elements. Actually. So now I was telling you that groups, they have the same number of valence electrons. Like when you check the periodic table, you will see that some elements are arranged vertically, while some are arranged horizontally. And vertically means like this, like as if it is coming up or coming down, while horizontal simply means like this. Horizontal is like your floor. What you are resting on now is like horizontal. Vertical is like your wall. That's vertical. So hot groups are vertical, while all periods, they are horizontal. Is that taken? Now, in case they ask you to identify groups in a periodic table of periods, groups has the same number of valence electrons. Valence electron simply means the last electron in the outermost shell. Every group must have the same thing. So if it is group 1, it simply means the last number of electrons in the outermost shell must be 1. For example, lithium has 1 at the back, at the last electron shell. You know, lithium is element number 3, atomic number 3. So that means it's 2,1. Sodium is also group 1. Why? Because it has 1 at the outermost shell. You know, sodium is atomic number 11. That would be 2,8, 1. So everything must always end with 1, 1, 1, 1 in group 1. Do you get the logic? For example, now, potassium. Potassium also is group 1. So atomic number, potassium belongs to atomic number 19. So that's 2,8, 8, 1. Do you get it now? But if you go to group 2, the outermost shell in group 2, the last number must be 2. It must be 2, like beryllium. Beryllium is element number 4, right, in the periodic table. That's 2,2. Like magnesium. Magnesium is 2,8, 2. You know, it has atomic number of 12. Like calcium now. Calcium is element number 20. That's 2,8, 8, 2. The thing that will last, the number that will last them must be the same thing. And it must correspond to their group number. So if this group 2, it must always end with 2, 2, 2, 2, 2, 2, 2. This is that taken. And if it is group 3, it must also end with 3, 3, 3, 3, 3, like boron, like aluminium. They must also end with 3, 3, 3. Please, is that taking confidence? And for the period, we say period has the same number of electron shell. The same number of electron shell simply means when you count the electron shell, it must be the same thing. For example, lithium that we were checking, it has 2 electron shell, 2 in the internal, 1 at the external. If you check beryllium too, beryllium has 2 external shell, 2 in the internal, 2 in the external. If you check What else? Carbon. Carbon has atomic number of, is not 6. So we have 2 in the internal, we have 4 in the external. But the number of shell is still 2. So period must have the same number of electron shell. Group must have the same number of valence electron. That is, the last number that is ending the shell must be the same thing for the group. But for the period, they must have the same number of electron shell, not the same number of valence electron, the same number of electron shell. Please, is that taken? So maybe next class, I will teach you, or should I quickly teach you? What's the time now? I want to teach you the properties, how you can understand what happened across the period or down the group in terms of atomic radius, ionization energy, because they'll be asking you a question on this one. You cannot even skip it. All this electron affinity, electronegativity. Should I quickly give it that before we move to the next, to the question and answer? Please, everybody, are we all clear now at the moment? Hope you're enjoying the class. Hope you are getting it. All right. So let's go to friends property. Let me just quickly give you this one and we end the class here so that we can move to the question and answer. So let's just move to property. Oh, the system is slow. Property across period. Sorry, please permit me to start the call. Okay. Let me dictate that for you. Most of our time. So we are talking about the property across period and down the group. Just write it like this in your notes. So when we talk about atomic radius, please write it in full. Atomic radius. Now, atomic radius, it decreases across the period and it increases down the group. It decreases across the period and it increases down the group. You don't need to understand. I will have proof to you what they mean by all these things. I don't want to bore. I don't want to bore you. Just understand, if possible. Just memorize it. It is only these atomic radius that decrease. Everything in the period, it increases. Do you get the logic? Every other thing, it increases. Only this atomic radius. So that's how to memorize in chemistry. So that's just the trend. And for this guy, every other thing decreases, apart from this one that increases. Do you get the logic? Do we all get the logic? So ionization energy increases across the period and it decreases down the group. Electronegativity. It increases. And I said everything increases. So this one will do what? To decreases. Electron affinity. It increases. This one decreases. Please, do we get that? Except for the atomic radius. Every other thing in across the period, every other property does what? The increases. Please, do we get that concept? And except for atomic radius, every other property, the decreases down the group. Please, do we get that? So we'll be ending the class here. So next week we will continue. I'll be next class, sorry. And we continue on chemical bonding. The other aspects. You know, I said I want to teach you atomicity and chemical bonding. So let's go to question and answer. Permit me to check for some questions. Please, do we all understand what we learned so far? We check how many topics today? 7. That's a lot. 7 topics today. 4. Hope you still remember everything. I trust you. What happened to Eze? Eze did not come to class today. Becky, Alpha, do you understand the class? Becky, are you there? Baraka, do you understand the class? Anisha Lua. Suzanne. Hey, where have you been? I was told you traveled out of the country. Is that true? I've been looking for you all this while. You had many times ago. Tag me along now. Involve me. Oh. I think I dreamt. I don't know who to. I had Gift this morning. Gift said she did not know. Don't mind me. So I'm trying to look for questions on what you just did. Give me some minutes. Please go back to the recording. It's very important. Titi, you are the last in this thing. Well, okay, so this is how we do it. Please, for those that are joining us for the first time, I'll be sending questions and you'll be picking it one after the other. So later, I will put you guys into group later, but not today. You have group A versus group B versus group C. You want to do quiz. So any group that want it, I will give you guys 10,000 there to just use it to buy a little thing to yours for yourself. So the first person that is going today is Becky. Becky, are you in the call? The second person is Confidence. The third person is Baraka. The fourth person is Gifts. I don't know why it is always the last person. Okay, it's because of your name, alphabet. No, it's not even alphabet now. Okay, it's because of alphabet. Let me change it. Thief. Are you the one that will tell me who will be in the group? Okay, Titi, you'll be the 5th person. What else? Ishelua, the 6th. Oh, Suzanne. That's 1, 2, 3, 4, 5, 6, 7, 8. So let's go, guys. So Becky, you are starting first, right? So this one is very simple. You must actually get it. And it's part of your jam question, so I don't understand it. If any one of you miss all this question, I will flog you. So Becky, what's the answer? Yeah, see how much you will love it. See? Why won't you love it? Becky, answer us there. A good girl. Are you there? Becky, are you there? When it is question and answer session, many people now be gentle. Eh? Can you type if that place is noisy, please? Hello. Should I call a friend for you? Becky, are you with us? You don't know it, have you? Okay, who is the next person? Confidence. Can you help her answer that question? Coffee. Confidence. So this girl, anything I post, she just like it. She's the first one that will like my posts on my social media. Pam, pam, or like gifts. Until I give her money, she will not like.
But the answer is C.
The answer is C.
Yes.
Yeah, very good. So the number of protons in an atom is equal to its atomic number. Yeah, you're right. Do you remember the formula for the mass number? Confidence. The mass number formula. Becky, it is not PO. Becky, are you with us since morning? These things are simple, fa. Becky, please go through the class again, like the class recording. Go through them again. Confidence, we are waiting for you. You guys are delaying us. Confidence. Coffee. Mass number. What is the formula for mass number? Confidence. Come for my handle. I will message your mommy. What is the formula for mass number? It's neutron plus proton now. Hey, all these things. Hey, I'm telling you guys, so okay, no problem. Okay, who is the third person? That's Baraka, right? This is down 2011. Baraka, are you there? Can you signify if you are still there? Very good. I trust you. Energy. You are not Yakubo, so sometimes it will be like make you give up. Don't give up. So down 2011, an atom has a mass number of 23. An atomic number of 11. How many neutrons does this contain? Do you remember the formula for neutrons? What do you say? Elder,
12.
12.
B.
The applaudissez.
B.
Applaudissez. You know, applaudissez. Clap for yourself.
Wọ́n sọ pé integrated science ní kọ́ máa ṣe fún ìwọ̀n ṣe basic science ni.
What is that saying? Are you from Chinese? Are you from China? Let me
What
speak
do you
China
say?
for you. I want to speak Chinese for you. I'm trying. I'm trying. Kind. I thought you were speaking Chinese, so I want us to speak Chinese together. Okay, who's the third
No,
person?
I don't. I don't get Chinese.
Eh. Have you
Yes.
answered now? You still want to answer another question?
Yes, I've answered the question.
Clap for yourself.
Thank you.
See, all right, gift over to you. If you miss it, I will come and kidnap you.
Shall be giving me food.
At the beginning, I know everything about you. You will fast, eh? You will blame yourself. Which scientists proposed the nuclear model of the atom? I gave you. Who discovered the nucleus? They want to use Oyinbo. You're not seeing the question, okay? Check your screen very well. Go back to your display.
It's Rutherford that discovered the nucleus, but I've not seen my question. I will log out and log in again.
Okay. Why are you not seeing the question?
Okay, I'm just seeing it. It's just appearing on my screen now.
Which scientists proposed the nuclear model of the atom? So sometimes they will not say which scientist proposed the nucleus. They can say which scientist proposed the nuclear model. It's also talking about the same thing. That is Rutherford. Is that taken? Huh? All right. So, do you remember the scientists that proposed what does that atomic theory state?
The matter is made up of indivisible atoms, and atoms of same element have identical, be similar properties.
You really tried. That's good. What about Thomson? Do you remember Thomson guy?
See, putting wait, let me go check.
Yeah.
Something putting the electron that is
And I was asking you guys to read after me. Some of you are making jest. Yeah, okay.
Okay, plum is plum.
Plum. Don't let your mouth spread. Plum. How do you know? It's okay. So who's the next person? Let me check. That's Titi. I want to look for one tough question for you. But I can't see. Very simple. Huh? Done. Up to 10. Up to 10. Which of the following particles has negligible mass? Do you know what it means by negligible?
Let me try. Should I say the answer I think is correct? Should I say the answer I think is correct? I'm not sure, but I just think.
You have to be sure. You know, if you can't tell Jam, like Jam, I'm not sure. Tell me the answer.
Electron.
Electron, yeah. Electron has
Oh,
negligible mass. So,
hey.
electron has the smallest mass compared to proton and neutron. Proton and neutron has 1, 1. Electron has 1 of, is it not 3486 or something? So it is very, very
183.
small mass. It has a very small mass compared to
Now tell them
proton
to
and
clap
neutron.
for me. Tell them to
What do
clap
you
for
say?
me. Tell
Clap
them
for
to clap
yourself.
for me.
Clap for yourself. See about. Who is the next person? Sheloa. Sheloa, are you still there? Very good. Please, for your mock, I will go and look for standard jam pass question. Because all these questions I'm seeing here from my school, all these questions looks very simple to me. I'm preparing for your jam now. What do you expect? You will check this. Every question I'm giving you on your mock, Friday test is actually jam pass question. Like, I just want you guys to be very familiar with your subjects, your past questions. So, Ishelo, over to you. Are you welcome there? Come and take me. Let's go for let's go for relaxation in Dubai.
The answer is A.
It's A. And this is very simple. Am looking at it? Saturday, you want to go to Dubai? Don't want to prepare for your exam again. A. Okay. All right, the answer is A. So, isotopes have the same atomic number, but different mass number. All these ones are very simple. Like I said, just get ready. Go and revise all your past tutorial notes. That we set standard 20 questions per subject. So you guys will do it. Everything, the 40 questions, you have to do it under 20 minutes. Simply means you are using 30 seconds for a question. Well, okay. So I want to prepare you so that you'll be very fast. And once it is time, you guys have to submit. You snap it to submit to the group. Anybody that does not submit before 20 minutes, you already missed the test. Is that taken? So make sure your phone is charged. After writing the answer, 1 A, B, 2 B, 3 C, you will snap it. You write chemistry on the first part, biology on the second part, you will snap it and send it to the group immediately. And write your name. If you submit answer sheet with that name, if I catch you, some of you don't want people to know that you score with the right. Don't worry, nobody will make jest of you. These are just learning phase. I've been in this phase before. So if you miss it, does not mean you are a failure. Just try it again. Yes, biology and chemistry in 20 minutes, 40 questions. You have to be very fast. 20 questions each. 20 questions each. That's 40 questions altogether. $20 is small. It's not so small. See you. Hey, Chineke. Who is the next person? Paul Abi. Paul, over to you guys. Don't mind them. All those ladies, only for food. They don't only food. The electronic configuration, this is down 2015. Atomic number 17 is what? All this question is just especially that within 2 minutes, I said 2 minutes, within 2 seconds, you'll have known the answer. Thank you, Jerry. 27. Baraka, you say it's too small. I think it's too much. Eh?
Sir, the time is small.
Paul, you too complain.
Sir, see, biology may not be the issue, but that chemistry, those
Ah,
calculations, those
okay, now
math.
40 questions for 20 minutes. It simply means you're supposed to spend how many seconds for one question? And anybody help me with that? It's not 30 seconds.
I agree with you, sir. You're building us. You're making us know have time management.
Exactly now.
But biology is the
Sincerely,
problem.
you can do it. I'm sincere, and you can do it. Have you guys went for a competition before?
Sir, like that 20 minutes is too small. Clearly, like 20 minutes, you just do two subjects in 20 minutes. How? Ha.
Hey, these people are
Suzanne, it's
protesting.
not small. Susie, my baby, it's not small.
Hey,
We'll do
you guys are
it.
protesting.
Oh, yeah,
You
now,
know,
talk.
when you
So,
get to the exam, all these threats, prayer, some of you will be shaking. You'll be shaking when you see
Yeah, I
sister,
know
you'll be
that
shaking.
you are doing as well.
I don't worry, we'll answer the questions. So, even though it's 10 minutes, safe, we'll answer the question. Don't
And now,
worry.
you guys have 2 hours for 4 subjects. I don't even know the number of hours you guys are using again. Okay, if it is 2 hours for 4 subjects, how many questions per each subject? And somebody help me, the last question, the last jam question.
English is always 60 and the rest are 40 questions.
So 40, 40, 40, that's 120. 120 plus 60, that's 180. So 180 questions for 2 hours. That's 180 questions for 120 minutes. That means you are spending 28 seconds for one question.
Sir,
So
sir,
it's equivalent to what I'm preparing you for now.
sir,
Yes?
the subject is not evenly matched. Like English, some first is kind of is easier than physics and chemistry. You can do English in less than
English is not easy.
less than 20
English is
minutes.
a technical question, it's technical
English is very
subject.
technical. Even me, when I did my jam, I had 66. It's not 66 or 67 in my English. English is very
Sir,
technical.
for
It's not
some
easy.
people, sir, it's easy for some people.
It's easy for some people. Yes, I understand. But it's English, eh? You can be picking it, and you're picking rubbish.
Sir, but
Just,
now if I'm going to do jam now, the last one I did, I used like 16 or so minutes for English, and I used 55 minutes
for
with
physics.
physics,
That one.
and I still had more in English than physics. That's what I'm saying.
Don't worry, I'm just preparing you. And you cannot change my mind. You are using 20 minutes for 40 questions. Just follow how I'm preparing you. After the whole everything, you will appreciate me. Don't worry. Just find a way to work with prayer and thought. I did something about physics. When it comes to calculation in physics, look at the units in the option. That will be the formula you have to use. For example, now, if I'm not, you are even diverting me. You can solve physics and mathematics very fast. Probably they ask you to find something, and the option is saying 30 meter per second, something meter per second. It simply means that the formula they expect you to use is something in distance, something you can measure, and something you can measure in time, something like distance over time. So definitely just know that in physics, it's just about being smart. Once you are used to the question, there's a way you can know by the question, especially when it's calculation question. You can check and know how to apply a formula and how to use it well. But that's just a derivation. But physics, don't waste time on physics. So physics is my best subject, and I'm very fast in physics. Just know what to do and do what you know how to do very fast. Biology is very simple also. So let's Barak, I don't mind them, Jare. From now on, you are not my new friend. I've left Suzanne and Gift alone. Those guys are. I don't know.
Milko.
Are you actually my friend? So you said 30. I should continue.
What did
Was
I
that?
do?
Who's the next person, Jerry? Suzanne is the last person. Okay, so that would be the last question for today. Let me look for a question. Those people, they are not serious. Only food. Which type of bond is formed by? I've not teach you bond though. That's the next question. Sorry, Susanna. Let me look for other questions for you. All right. Can you still see the question? I don't understand though. Which question? Susanna, I'm coming. I'm trying to look for a new question for you. Don't mind them. Okay. Okay, let me paste it. Let me paste it. It's actually very simple. It's just that I've not taught you, so I don't know if you guys know bonding before. I think I see a question now. 2021. So Suzanne. Suzanne, do this. Now this question now, if I'm the one, I can't spend more than 10 seconds. It's not even possible. Titi, this is a question. Suzanne, do you have an answer to the question? I've taught you guys relative atomic mass before. I taught you today. Titi, are you still there?
Yes, sir.
Okay, are you still calculating?
Yes, sir. I'm calculating Suzanne's one, but I've gotten that one, so I'll check the next one.
Okay. One of the easiest subjects we can pass easily is chemistry, followed by physics, followed by biology. Personally, for me, for a science for a science student, you don't know the formula for RAM. Do you know the formula for the code? Or which RAM are you talking about? Is it RAM for animal? I'm just joking. Oh. I can't tell you the formula. You want to do it? Oh. I've given you before now. Were you not in the class when I was teaching you RAM? Becky. Or who asked the question? Covalent bond. What was the question? What type of bond is formed by sharing of electrons between?
Yes, I'm not in the.
We're not in the class. Please go and watch the video. Yeah, you are right, Titi. Equivalent bond involves sharing of electron. I will teach you in the next class. Actually, I plan to finish this class before. It only remain that part. It remain bond, chemical bonds. That's the only part that remain. I will teach you all these coordinates, bond, and the metallic bonds. And I think shape. They always ask shape also. And ask what is the shape of water? Is it linear? Is it pyramidal? Is it tetrahedral? Things like that. So after that one, I believe you should be able to. Yeah, correct, but is the answer. Yeah, Suzanne, you did not do your question. You are doing another question. This life, eh? Who know how to do Indian dance? Yeah? You can dance Indian. Yeah. Suzanne, you can dance. Ah, Isheluwa. Me too, I can dance in India very well. I like the dancer. I, hey, dancer. Ah, that's good. Maybe I'm not a dancer. I'm a footballer. Yeah. I don't answer. Let's leave Suzanne alone. Suzanne, how many minutes more should we give you? It is already time. Oh, we spent 2 hours already. I just want to see you two can dance. No, one day we do get together. So I will see how you guys will dance. Dance is not life. Oh. So gift. Food is life. So gift. So Suzanne, should we move on? So I think Becky said she did not know the formula. The formula is summation of, you don't know the question. We did it the other time now. But you're not in the class. Maybe you joined late. 63.62. I've not even done it. I've not done it. So let me quickly do it. So let's see. Titi, what do you get?
I got 2.28.
3.28.
2.28.
2.28.
Yes, sir.
I'm not sure that would be correct. So relative atomic mass is equal to summation of what? Isotopic mass, right?
No, sir, it's not correct. I said another one.
I know it's not correct. Multiply by the percentage abundance. Everything over 100. Do you guys remember? You will multiply individual mass by percentage abundance and you will add them together. You divide everything by 100. So let's start. So the first one they gave us here is it not 63? So that would be 63 times 69, right? What's the second mass? Atomic mass is 65 here. That would be 65 times. What's the percentage abundance? That's 31, Abby. Becky, do you understand? Then you divide by 100. Becky, do you get it? Suzanne, do you get it? So this is the formula that you have to use. You use isotopic mass multiplied by percentage abundance. Everything divided by 100. So you multiply your isotopic mass. The isotopic mass is one that's at the top left. You multiply by your abundance. Then you add it together with the second isotopic mass after multiplying by the abundance. Then you divide it by 100. Becky, do you get that? Okay, it's louder. You don't get it. Okay, let me come again. I gave you this formula the other time. I don't know if you're in class. Relative atomic mass is summation. Summation simply means plus. You add your isotopic mass, or call it isotopic mass. You multiply it by percentage abundance. Is that taken? Then you divide the whole thing by 100. Is that taken? So now, what is isotopic mass? Isotopic mass is the one that is always at the top left. Top left. Now they gave us 63x. They gave us 65x. So the atomic mass for the first one is 63. Isotopic mass. The isotopic mass for the second one is 65. The percentage abundance for the first one is 69. Percentage abundance is what? 69 for the first one. For the second one, the percentage abundance is 31. Do you get it now? So now you now slot it inside this formula. This formula said summation simply means addition of the first isotopic mass multiplied by the percentage abundance. So the first isotopic mass is 63. So that would be 63 multiplied by, what is the percentage abundance? Is it not 69? Multiplied by 69. Since it says summation simply means plus. So you put this one into brackets plus the second isotopic mass, which is 65, right? Dauda or Baraka. So that would be 65 multiplied by, what is the percentage abundance of the second one? Is it not 31? That's 31. Everything divided by 100. So you will calculate it. I'm not a calculator. So you multiply 60 times 69. Is anybody there? Let's quickly do it before we call it a day. 60 times 69 is what? Somebody help me. 60 times 69 is what?
4,692.
692. For 63 times 69.
Yes, 4,692.
92. Okay. But 3 times 9 is 27. Oh. 7 should be the one that we hand it to.
4,347.
Okay. Thank you. I was trying to wonder, like, should not be 65 times 31.
2,275.
275.
Yes, sir.
Are you sure? You shouldn't be up to that. Oh.
2015.
Yeah, are you guys taking a call this morning? Suzanne, Titi.
2015.
Titi, what happened to you? Divided by 100.
Sir, sorry, 215.
So what is 4347 plus 2015? So this will be 5 plus 7, 12, 2, 1, 1, 4. This is 6. 0 plus 3. This is 3. This is 6. Because I don't. So divided by 100, that would be 63. Okay. So I think 2 people said 63.62. I think gift and it's not Titi. So Dauda, did you get it now? Did you get it now?
Yes, sir.
All right. So do you have anybody that wants to ask any question? We are 8 minutes late already. Sorry guys for taking your time. Any other person? Hey, Suzanne, do you want to say anything?
Sir, actually, this 63 62 over 100. How did you get to put it?
This what?
Like the 62 and 600 and sorry 6,000.
Hello, I can't hear you.
6,000 and
Hello, Suzanne, are you saying something?
yes, I'm saying something. This 6,262 over 100, right? When you calculated it, how did you get 62.62?
Hello, can you guys hear me? So I think this is on network. So I would like to end the call here. Please, thank you for today. Next class, we'll finish our chemical bonding. And after the class, no, it is after the test, we'll do the class. We do the class. We do the class after the test. Check it. So the first thing we are doing on Friday. Maybe I will do a little bit of revision. I may not do revision depending, but all of you should. I have king for you. King, king, king. I have something for you. I don't think I've ever given you something before. So
Yes, sir. You've never given me something
you guys
before.
should, what am I even saying? Please be punctual for the test. Be punctual. If you join late on Friday, we should start the test. On Friday, I should have you what time, sir? Is it not 10 a.m.? So we should start the test. We are starting the test 10:30. So if you don't join the class before 10:30, you are not permitted to take the class, to take the test. So how that is taken. Anything you are doing by 10, please stop it so that you can attend the class. But even though you are running away from question, I don't want people to see my answer. That one is your own cup of tea because you will still do your exam. Eh? So it's better you prepare yourself ahead of time. You can fail now and pass your exam very well. The most important thing is for you to do excellently well in your exam. And these are the little steps that you need to ensure that you are doing well. Is that okay? So we meet tomorrow for your biology. So do well to have a good day and enjoy your day. Bye bye. So let me see your love emoji before you go. Thank you. Grace. What happened, Grace? Hey, you're not giving up emoji, you're giving hey, what is that? What did I do to you? Suzanne, what did I do? You're not serious. Thank you, Jerry Becky. Thank you. Yeah, Titi. Don't worry, we'll see now. Take care of yourself, yeah. And Baraka, take care too. Yeah, bye bye.